Let's perform and evaluate polynomial regression using the data frame we created in the last video. So in order for the evaluation part, I want to have a training set and a test set. So let's, from sklearn.model selection, import train test split. And then let's do train test split. And here I want to say what are my inputs going to be. So I'm going to do the data frame and then just these columns, the x1, x2, x6 columns. So that's going to be like my inputs, those 6 columns. Those are the 6 things I want to find coefficients for. And then the outputs are going to be dfy. And I'm going to say how big do I want my training set to be. So I'm going to say train size equals, and let's start out with it being small. So there are 1,000 different rows, but I'm just going to take 20 of them for my training set. Okay, so smaller the training set, the more likely there is to be overfitting. And just so that my numbers are the same each time, I'm going to specify a random state, but I didn't have to work as hard to find a random state that I liked in this case. I just did random state equals 0. Okay, and then let's call these xtrain, xtest. Okay, so this is going to have 20 rows. This is going to have 980 rows, all the rest. Okay, and then similarly for ytrain and ytest. So I'm using tuple unpacking in this case. And now let's go through and perform polynomial regression for degree 1, for degree 2, and so on. So I'm going to use a for loop for I in range from 1 up to 6, so max degree plus 1. And then what I want to do is I want to make a new linear regression object. Okay, so I guess I should remember to import that. So from sklearn.linearModel, import linear regression. Okay, and then so for degree 1, for degree 2, and for all of those, I'm going to instantiate a new linear regression object. And then I want to fit it, but I'm just going to fit it using some of the columns. Okay, so when I is 1, I want to use 1 column. When I is 2, I want to use 2 columns, and so on. So this I is like the degree of the polynomial. So I'm going to say my list of subcolumns equals columns, give me the first I. Okay, and let's just print these out so we can see what they look like. Okay, so first I'm going to use just 1 column. At the end, I'm going to use all 6 columns from my df calls. Okay, so let's copy this and paste it. Okay, and so what do I want to do with these subcalls? Well, I want to fit the regression object. So reg.fit, and I just want to use this subset of the columns, of the polynomial columns. And then for the outputs, I want to use y. And do you see what I'm doing wrong here? Well, I'm not using the training set or the test set. So let's replace this with xtrain, and let's replace this with ytrain. Okay, and now I want to evaluate how it's doing. So let me add one more thing up here. I'm going to say from sklearn.metrics, import mean squared error. And so when scikit-learn is performing linear regression, it's trying to find what are the coefficients that minimize the mean squared error. And so let's check. So I'm just going to print it out. I'm going to say mean squared error. And then there need to be 2 things inside of here, my prediction and the true values. So let's do it for the training set first. So I'm going to do reg.predict xtrain subcalls. So this thing here is one of my 2 inputs to mean squared error. So what should the other thing be? Well, it should be the correct values corresponding to xtrain. So xtrain is like the input, and output is ytrain. And what I want you to notice is, see how these numbers are decreasing? And that's very much characteristic of fitting and predicting both on a training set. If you make your model more flexible, like we do when we increase this degree, the error should be going down, which is like saying the performance is better. So let me save this under, how about train error dictionary? Okay, so that's going to be a blank dictionary to start. And then for the key I, like I equals 2 in the dictionary, the value is going to be this mean squared error. Okay, and so if I check this train error dictionary, I should see the exact same numbers as I just saw in the values column, and I also know what degree they correspond to. Okay, great. And let's also make a test error dictionary. And this is going to be like the exact same thing. So I'm still fitting on the training data. In general, you always want to fit on the training data. But here I'm going to evaluate it on the test data. And that's much more representative. So I want to do X test for my inputs and Y test for my outputs. Okay, and if we look at this test error dictionary, so what I want you to notice here is that it goes down as we get to the correct degree. Okay, so like this minimum is at degree 2, and then it goes up a little bit, goes up a little bit more, and then suddenly like the overfitting starts going crazy at this point. So at degree 5 and degree 6, we have like a much bigger error. So it's like, if we were looking at the training error, we would have thought degree 5 was great. But if we look at the test error, okay, which is what you should look at because the test set is what can detect overfitting, then we see that degree 5 is performing very badly. So I think that's all I'll do in this video, and then we'll try basically the exact same thing, but with a larger training set in the next video.